Okay, cool. Alrighty, so were you guys able to do part 1?
Yeah.
Okay, perfect. I was looking at part 2. I haven't done it yet, but it looks really easy actually. Um, so I think that'll be good. Okay. Um, did you guys get a chance to look at part 2? Like
I
not do
did.
it, but look at it?
I started doing the first part, design the study, but it's totally different than what their answer was. I'm like, okay.
Oh, okay. Well, let's go ahead and I'll just go ahead and read it. Well, the first part says match paired T procedure. A manager at a factory feels that the amount of time that his workers spend doing their part in the assembly line is too long. To determine if a new assembly procedure is effective in reducing the time, he measures the amount of time in minutes, um, measures the time of 9 of his workers to complete 100 products. Oh, oh, okay. Oh, okay. He measures the amount of time 9 of his workers take to complete 100 products. After implementing the new procedure, he again measures the amount of time in minutes the same 9 workers take to complete 100 products and obtains the following data. He wants to know if the mean assembly time is different and use the level of significance of A equals 0.05. Okay. Okay. So design the study. What is the research question? So I got
I put if the new assembly procedure is effective in reducing the time employees do their part on the assembly line. That's what I put, but that's not what they have on the answer.
okay. So I was just gonna say, is the mean assembly time different when when the nine workers um, complete the trial time? What do they have for the answer?
You're more on target because it's more specific to the 9 test group.
Okay, that makes sense. Does that make sense to you guys?
Yeah, I think I just needed to see an example of it. This is our first time doing like a more thorough step-by-step thing, you know? So I kind of needed to see it.
Okay, perfect. All right. Okay, cool. Yeah, that makes sense. Cool. And then B, it says state the null and alternative hypothesis. Um, so the null equals 0. Mhm.
See, there I put words. I put the productivity on the assembly line is acceptable. That's like that's what that would be the null. That would be the widely accepted view. But what they're challenging is if they could be more efficient with their assembly line. That would be the alternative. But they just have it in the actual, you know, what do they call that? Like equation type.
Uh-huh. Yeah, because I think when it means 0, that is like the what do they call it? That's like the mean, I guess you could say. When it's 0, that's the mean, and so then the alternative is that it's not. What they're thinking is that it's not going to be equal to the mean.
Right. Anytime that's something that is different, that's when it's not equal to. It's not saying it's less or greater or anything. It's just not the same. Different. So that's when you use the equal crossed out.
Yeah.
Right.
Cool. Does that make sense to you, Elena?
Are you in the common room or something?
Yeah, I'm in one of the study rooms.
Oh, study room. Oh, okay.
Cool.
There are people calling you in the background.
Yeah, I know people walking by.
That's fine. Cool. Well, awesome. Then, should we do number 2?
Sure.
Alrighty. So number 2 says, collect the data. Describe the data collection procedures.
Well, what did they do? They collected, they had 9 people in their test group. So that would be how they collect data. They would analyze their efficiency with 9 people, the 9 people.
9 people to do one product. Okay. Let's see what the answer was. It says, after implementing the new loading or unloading procedure is the mean weight. Oh, sorry, wrong one. The researcher collected assembly times in minutes from 9 factory workers before the change. Then he collected the assembly times for those same 9 workers after the change procedure. Yeah, perfect. Cool. And then, number 3. Oh, sorry, that is number 3. Oh no, number 3.
Are we ever supposed
Describe.
to turn in these things or anywhere, or we should just keep them for our own personal records?
Yeah, because I haven't seen anywhere to turn them in, so I
Okay.
just think we're supposed to keep them for our own personal record, I
Okay.
guess. That's what I thought, at least. I
Yeah,
hope it's that
it's
way.
the same thing as the homework. It's just for our own records and benefit. It's not necessarily to turn it in.
Yeah, that's true. Cool. Alright. Number 3. Describe the data. In a short paragraph, use summary statistics to describe the data. After the paragraph, insert an appropriate and well-labeled graph to illustrate the data.
Okay, so we need to use SPSS.
Yeah, I think so.
All right. So go to descriptive statistics and then explore or descriptives. I'm trying to remember.
What do you mean?
When you go into SPSS, are you under Analyze, Descriptive Statistics, and then Descriptives?
Yeah, let me just get there real quick.
I think Explore will work. Let's see.
Hey, did you guys know that we have a test next week?
Yeah, it's like the worst time ever to have a test, but yes.
Is it super busy for you over there?
Yeah, I think I'm going to start studying for it on Sunday, even though that might be sacrilegious, but but I have my daughter and my son, both their birthdays party is next Saturday, or the 28th, Saturday the 28th. So
Oh, that's fun.
they're both having a birthday. So they're one day apart birthdays, but 6 years apart in age. So.
Oh, that's fun.
Yeah, but not having an exam is not fun. Okay.
Yeah.
Anyhow, I'll work it out. All right, so we're in SPSS. We're going to find out our summary statistics. Did you guys go to Explore or did you go to Descriptives?
Mine's still trying to load. Mine's taking forever.
Oh, okay, never mind.
Sorry.
Excuse me.
Let me see if I can just pull it up in Excel. Let's see if that'd be fast.
Okay, let me see if I can. Okay. I'm in Descriptives. So, I mean, you can do the summary there. The minimum is 1160, the maximum is 8180, the mean has a standard deviation, has that information. And I think that's what they want, right?
Yeah, I think so. Yeah.
Let me see what the answer says in the... okay. What's D bar? I don't know what that means. Okay, yeah, that's what they want.
There we go. Now it's coming up.
This,
Oh, that was taking a long time. Sorry. So you went to. SPSS is pretty neat.
I think so too. I like it a lot more than Excel.
Yeah. Now that I know how to use it, I like it a lot more. At first, I was like, oh, no, I just want Excel.
Right.
But then how to use it. It's really cool.
But did you guys have a problem figuring out how to do the subtraction step today in the exercise in the textbook?
Which part was that?
Oh, we were supposed to go through the exercise of actually subtracting the two groups, the pre and the after, or whatever, the two groups or whatever, in the first part of the textbook exercise. Like nothing was coming up for me, so I was either I was obviously doing something wrong. So you guys didn't have problems with that?
I didn't do that part, so maybe
Oh, you didn't?
No.
Because you know what I'm talking about, Elena?
No, I don't. Sorry.
But
when you read through the online textbook and there's a part where it says now go in SPS, open up Mahoney or Mahone, whatever that study was, and then you're supposed to actually practice subtracting the two means or whatever. You guys didn't do that yet? Okay.
No, I remember reading that. I didn't do it though, but I remember reading that.
Okay.
So,
like there wasn't any data coming up for me, so I was wondering, what am I doing wrong?
Yeah. Where's mine?
Okay, so right now we're on number 3, summary statistics. So what I did is everyone went to analyze descriptive statistics and then descriptives, and that's how I got it.
Yeah, you went to analyze. Oh, okay, yeah. I went through
descriptive statistics and then descriptives.
Okay.
And then I put both into for the variables because you're dealing with two different means, so the minimum and the maximum. So the pre-assembly change and the post-assembly change is what I mean. So.
Okay. Yeah. So I got. Okay, and then we can just.
But you know what? It's coming up differently though. So maybe I'm doing something wrong. Okay. Boy, where's Victoria when you need her? Okay. Are you getting that information?
Yeah, Yeah, I got it. What did you get for the first one, like for the minimum?
11.60.
Okay, that's what I got. And then for the second minimum, what'd you get?
1070.
Okay, yeah, that's what I got too.
Okay.
So oh, okay, yeah, yeah. For some reason, I thought they both said post-assembly chain. Um, but so the first one is the pre, and it's just like, um, okay, I got it now.
But we all got that, but that's not the answer when I looked at the answer key. So
Really?
no, it's not. It says the population is n equals 9. We got that right. But
Mhm.
its d bar equals 1.056, and the standard deviation is 2.596. So that's what they said in the answer. So we can go back and figure out what's going on.
Let's see if we just do it with just one of them.
Yeah, that's what I'm thinking too. Maybe we need to go back and just do it with one variable.
Yeah. I'm gonna do with the pre.
Okay, I'm going to try that too.
Well, it still has all the same information that we had. That's so weird.
Okay, I wonder if we have to go into options. Okay, so we want to know, I don't know what D bar represents. I'm trying to think what D bar means.
Yeah, that's what I was trying to think about too.
Probably something that is very obvious, but we haven't really heard it called that yet. Okay.
Yeah. Because, yeah, I don't remember seeing anything in the reading with the D bar. So I know that. Let's check to see if there are videos.
Okay. Are we supposed to subtract here? And maybe that's what we're supposed to do?
Oh, yes, yes. Good
Okay.
job.
Okay,
Yeah, I
so
think that's what we're supposed to do.
we're supposed to track the two minimums. Maybe that's how they got D bar 10. Let's say, let's try that.
Let's go. No,
That's not working?
no, that's not what I got. So let's
Okay.
that
Not.
one.
Okay. That's 0.9.
Oh, okay. I think I might know what it is actually. Oh, okay. Yeah, that's what the D with the bar over it, that's the mean. Like that's what track both means.
Okay.
Yeah. And then the standard deviation, we just subtract both standard deviations, I believe.
Okay, but how did you get D bar? Did you get that answer, 1.056?
Uh-huh. Yeah, so you just you look at both of the means. So you look at the mean for the pre-assembly change
Uh-huh.
and post-assembly, and you just subtract the 42.9778 minus 41.9222.
Oh, okay.
The 1.056.
Okay. I was on the right track. I knew there was something to do with subtraction. Okay.
Yeah, good job.
Oh, thanks. Okay. All right. Now I got it. Oh, hooray for that. Okay. Okay. Now I didn't get the same answer in the standard deviation. You just subtracted the two?
Yeah, I ended up not getting that one either.
Okay.
SD. let's see.
Okay.
So I'm just trying to
I
look.
think there was. I'm trying to think where we could find that information. There's supposed to be a tutorial on the SPSS at the end of our textbook unit this time. I don't know. I haven't checked that yet.
Yeah, that's what I'm going through right now. Just see. Oh man. Oh, SD, that's what it was. Oh, okay, here we go. Okay, the sample standard deviation of the differences is denoted S sub D. Oh, so what were we doing wrong? Okay, let me go through this. Okay, yeah, so the sample standard deviation. So let's see if we do this.
Okay.
Let's see. Let's see. So I'm gonna try to find something real quick. We are on. So I'm just gonna listen to a video, so you might hear the sound.
Okay, so we're going to do this on Excel. Okay, so we can get all of our information from the factory side this time. Question. Now, real quick, just to remind you how to load the data in, you go to Open, Data, and then wherever your data is at, you should grab it. Open that up. Now, the first thing that we need to do is we need to make a new variable. That variable is difference. So we're going to come up here to data, and then, oh, excuse me, sorry, transform, and compute variable. Up in that top left corner, I'm going to call it variable the difference. That's what it's just to one between the other. And so we'll do post, put that, and minus 3. Okay, so now our new variable is going to be post score minus 3. preschool. Okay, so here is our difference column right here, this third column. And now it's this third column that we're going to run the statistics on. So first off, we like to get this. So we're going to come down to descriptive statistics and explore, like we've done in the past. But this time, instead of putting in one of the columns that's given to us, we're going to be using difference. Okay, just double check. We want a 95% interval. Plots, we want a histogram, and then eventually we'll probably want a QQ plot, so I'll add that in there right now. Okay. Output, we get our statistics. So first off, here is the graph. And right here is are the statistics. Here's the 1.055. Here is the standard deviation of 2.6.
Okay. Okay, so the way he did that, so do you know where to find these videos?
It's was it in the textbook?
No, if you just find, so you know where you can access the textbook, just like on the Learn page. So at the very bottom it says video tutorials.
Okay.
And if you just click on that, it pulls up like a video for every problem.
Really?
Yeah, so that's really nice. Where did it? Oh yeah, that's it.
Yeah, I mean.
So here he was okay, so you go to okay. File. Okay, so if you go on to where you can see all of the data, or just like the one with all of the, it looks like the spreadsheet.
Right.
So if you go on there and, okay, his is different. Oh wait, nope, just joking. So if you click on File and then the menu drops down and you click on Read Text Data. Okay, hold on, let me see where he got that. Read Text Data.
Okay.
Go to
oh, just joking. You go to on File. You go to Open Data. So you go to Open, and then there's that little arrow, and then you go to Data, and you click on that. Why is this totally different? Where did mine go? Where did it go? Oh. Okay, so if you go to Open Data, then do you see the one? Oh, you'll just have to find it. We're at the. Where is it? What's the one called? Oh, factory assembly. Right, okay. Oh, there it is. Okay. So you just double click on the factory line. And then mine pulls up like revert to saved. Wait.
Right. That's because we're the files in use right now. We're using it.
Yeah. So if you just go to open in a new window, I think that's what it is. Mine is being looked at differently, but whatever. Okay, that's weird. So then after that, sorry, this is taking a while.
Open that up. Okay, now the first thing that we need to do is we need to make a new variable. That variable needs to make a difference. So we're going to come up here to data, and then, oh, excuse me, sorry, transform, and then compute variable.
Okay. So
I
if you
heard
go,
that. Transform compute variable. Okay.
so data or
This
transform.
is the part I was trying to convey to both of you, that you're supposed to practice in the textbook exercises, and I couldn't figure out how to do it. So perhaps you can help me.
Okay, yeah. So then, did you see where it brought up a new? It kind of looks like a calculator type thing.
Yes. Yes, I'm on that right now.
Okay, so then for the target variable, we can just put difference because that's what
That's
we're
what I
finding.
put earlier, and it okay.
And then and then we'll put on the left-hand side where it says post-assembly change, we'll add that one into the new box.
To the numeric expression, or to?
Uh-huh. Yeah, yeah. And then, so you'll put the post-assembly change minus the
Okay.
pre-assembly change.
Okay.
And then let me just see what he did.
Okay.
In that top left corner, I'm going to call it I'm going to call the variable the difference. That's what it is, difference of one to another. So we'll do post, I'm going to put that minus. So now our new variable is going to be the post score minus the pre-score.
Just push OK.
So here is our difference column, right? Here's the column. And now it's this third column that we're going to run the statistics on. So first off, we're going to come down to this.
Okay, cool. So now we will click OK, and then after that we will see that there's the new one, the difference. And then we'll go up to Analyze, just like how we normally do, and then go to Descriptive Statistics, and then Descriptives. But instead of putting the pre or post assembly change, we'll put the difference in.
Ah.
We'll put
So that's what
OK.
you're talking about. You have to do that step in order to do the regular hypothesis test. Okay.
Yeah. And yay, it worked. So it's like
good job. Good job, smarty pants.
thanks.
Okay. So that's now we got the standard deviation 2.596.
Cool. Yeah,
And
perfect.
the mean. It's negative, but I guess that doesn't matter.
Yeah, that's what I was just looking at. But yeah, I guess. Okay.
Because it's a difference. So.
Yeah. Well, perfect. I don't know how he did that, but okay. And then another way, and then
go
we have
through that
to go
again.
and then we have to go in and put in a graph for
Yeah.
this. I'll see how he did that.
Did he do a histogram?
Instead of putting in one of the columns that's given to us, we're going to be using the difference.
Oh, okay. So it's in that same thing.
So it would be probably graph and then histogram?
Yeah. Can you actually do that?
I'm sorry?
So if you go back to the same thing, the analyze, descriptive statistics, and then descriptives.
Uh-huh.
He had something else. Let me see if I can find that real quick. Well, his was different, so let's go. Yeah, maybe to graphs and chart builder. Oh, mine it has graphs and then legacy dialogues.
Yeah, that's what I was going to recommend is the legacy dialogues, how you get to the graphs.
Oh,
And then go down to histogram.
And then
So we put indifference in the variable, I guess.
Yeah, I think so. That's what I was just gonna do.
Okay. So I got a little.
Okay, there we go. Mine's just loading. Oh, perfect.
It kind of looks bell-shaped, normally distributed.
Yeah, it does. A little bit.
Yeah.
Cool.
Mhm.
Well, awesome. Well, perfect.
We should cut and paste that, or what? I don't know.
Yeah, we can. It's a good idea.
Or I'm trying to remember how you take a snippet or whatever you do, just snip a picture or something.
Oh, yeah, that's a good idea. I'm not very good at that stuff. My wife knows how to do that.
Yeah, me either. I'm not either.
I just did copy and then paste it.
Yeah.
But oh, hey, we're looking.
I'm gonna do that.
Oh, cool. And then on the side of the graph, it actually has the mean, standard deviation, and the
Yeah.
numbers.
Perfect. We could have just like went straight to that, right? You got
Yeah.
all that.
Oh, cool.
Yeah, that's how we learn.
Yeah. Alrighty. So then, number 4, make inferences. What type of hypothesis test is appropriate? Are they talking about? There was the matched pair, or are they talking, or the matched pairs, or one sample? Well, we know what the standard deviation is, so would it be the matched pair t?
Hold on, I'm not there yet.
Okay.
I was cutting and pasting. Okay. Okay. So we're on make inference on number 4.
Yeah.
Is that what you're on? Okay.
Uh-huh.
What type of hypothesis test is appropriate?
So I think it would have to be the matched pair t, because the one sample t, that one is for if the standard deviation isn't known. But since
Okay.
we do know it, it says we could do the matched pairs. And I did check the answer because I thought that was just it, but it says a two-tailed paired sample t-test for means in the appropriate hypothesis test to perform. So we were close to.
Right. I think in a more common language, you're saying the same thing they're saying.
Yeah.
Okay, so two-tailed hypothesis test.
A two-tailed matched pairs t-test.
So is it two-tailed because we're dealing with two different means? Is that why?
Yeah.
I'm trying to remember the logical explanation behind it, so I can connect concepts together, you know.
Uh-huh.
Uh-huh. Let's see. Looking at my notes.
So this is.
Okay, because we don't know the z-score, so that goes back to our last unit. We're dealing with a t-score because we have
So I do see,
one area in the tails.
yeah. So I do see in the summary it says the alternative hypothesis can be left-tailed, which has the little sign like the less than sign, or right-tailed, which is the right or the greater than sign, or two-tailed, which is it doesn't equal the null hypothesis.
There's your key right there. In the hypothesis test, we said not equal. That's what we're for the alternative test. Okay.
Well, awesome. Yeah, so that makes sense then. Since it doesn't equal the original one, it's the two-tailed. Oh, that makes sense. Cool. And then what are the requirements for this test?
That's normally distributed, random sample, right?
Normally distributed. And then it also has to be, the requirements for this test, it has to be like the same people doing the test.
Right.
Um,
So the same test group.
uh, and doing the same thing. Exactly. Doing the exact same. Oh, the question's a little different.
All right. So what did the answers say for B? Are we right? I haven't checked it.
Yeah, we are. It just says a little different. It says we assume a simple random sample of the population.
Right.
With a sample of less than 30. So we need to make a QQ plot in order to test the normality of the data. Well, that's a different question, though. It says, are the requirements met for this test? Explain. So I think what we said was right, because the question is a little different. I've noticed that a couple times. So yeah, I think what we said was correct.
Okay.
Oh, cool. Alrighty, so then C. Well, it says compute the difference between the two times and determine if the requirements are met for this test. Okay.
Okay. So that's dealing with the level of significance. What was that? The alpha was 0.05, and we have do we have a p-value? Or in this case, it's not a p-value, it's a t-value. Remember we studied that p-value is greater or bigger than you reject. I'm trying to remember.
Yeah, I remember that.
Okay, where's if the p-value is less than the object, the null hypothesis. So
Cool.
the question is, did we have a p-value in this particular test? Or what are we comparing to decide that? We know the alpha. The alpha is given us, provided for us.
Mm-hmm. So it does say, I know for
Sure.
we're going to need to, it says compute the p-value to the alpha level. Oh, okay. So.
Okay. So the p-value is the same thing as the area and the applet. So if we knew, that's the probability, p-value. That's the part on the top of the applet, the area. Okay, so I'm trying to think how we get that.
So yeah, I think we do need to find what t equals.
I'm sorry?
I think what you were saying earlier, how we need to find what t equals.
Yeah.
Because I did just go to the textbook online, and I typed in test statistic, and it what we have to do, t equals, would that be the mean minus, minus the null hypothesis?
Yeah, the t-score is t equals x bar minus the little funny u over s
Oh,
divided by square root of n, right?
yeah, yeah. Cool. So
So do
then,
we have all that information to do that? Let's see.
yeah, so t equals, so the x, that's the mean, which we know is negative 1.06, right?
Yeah, yeah, it's the same thing as d bar. It's the population mean, but in this case, they so you know it's that kind of test. They give it a d bar name instead of an x bar name.
Yeah.
Yeah.
Minus 0, because the null hypothesis is 0.
Yes.
And then S, what is
Be right back.
Yeah, you're fine.
Okay. All right. So S
So
S is the standard deviation, so it would be 2.5, right? That number, 2.596.
Yeah, that's what I
Okay.
got.
And then the N is 9.
Okay, yeah. So then I got negative 1.22, but then the key says 1.22. So the mean must be positive then. I don't know.
You got a different answer than me. Okay, I got 0.135, so my order operations must be wrong. Okay. Did you do the denominator first and then?
Yeah, so I just did negative 1.056 divided by, in parentheses, 2.596 divided by the square root of 9.
Okay. So you got 1.220, you said?
Yes.
Okay. Okay, so that's our t-score. So we could put that into the applet, and that would give us, or we can just use that to compare with the alpha. Or no, we've got to put it in, excuse me, we got to put it into the applet. So. Okay, let's see.
I do know that for the test statistic, it is C. That's just all we're looking for C. So our answer is T equals 1.22.
Okay.
And then for D, it says state the degree of freedom. Do you remember how to do that? I remember learning about that last week. But
It's df is equal to the n minus 1. So what our n was, it's minus 1 from that.
okay, so then that would be
8.
df equals 8.
8, right?
Oh, okay. So you said the degree of freedom is n minus 1.
Yeah.
Oh, okay, that's easy to remember then. Cool.
I actually remember one of them. Yeah.
Then E says compute the p-value to the alpha level. So the p-value, so do we just find p equals...
So we just put in the applet and get it that way. So it's a two-tailed, so we're going to shade the two tails, and that should give us the piece value, which is basically the probability in the area.
Yeah.
So we need to find, where did I put the applet? Okay. Had it open. All right, so the both areas shaded. Put in 1.220. Okay, so the area I got 0.2225.
Yeah, that's what I got. 0.225. Yeah, that's what I got.
Okay, so we compare that to the alpha level, which is area significance. Okay. Okay, so the p-value is less than the alpha, which in this case it's not, it's greater. So we failed to reject. Because the rule is that the p-value is less than the alpha, you reject the null hypothesis. But that's not the case. The p-value is greater. So we have to fail to reject it. Is that agreeable to everyone, or am I wrong on that?
Yeah, no, I agree with you.
Okay.
So the p-value, what the key says is 0.257. I wonder if they just put in like a slightly different number, which maybe made it a little different.
Well, when it comes to taking the quiz, you can't be slightly different. It doesn't count. Either you know it or you don't. So, I don't know what we're not getting here. I'm trying to think. Because there's so many similar terms for the same thing. You know, we're talking about z-score, t-score. It's like the same thing, but it's just based on one different variable, or, you know. So when you don't know sigma, that's how you do the t-score versus the z-score. Okay, so What do we want to do?
Yeah, I'm just trying to figure something out real quick.
No problem.
Yeah, because when I enter it in, I can't even get 0.257.
Okay.
I
So,
don't know. I know that they've made errors before, so because what it says in the instruction is to put the T score, what we got, into the probability applet, and we should get that for the area. So maybe they just made a typo.
okay. You feel comfortable with that?
And then it says number G or letter G, present your conclusion in the form of an English statement. Kind of what we just said last time.
That means you have to do it with an English accent. Sorry, is it too late for any corny humor? Okay, I'll refrain. Don't worry, I'm not going to try my accent, even though I do watch Downtown Abbey, but I'm not going to try my accent.
Not do English accents for the life of me.
Can you imagine living in that society? Oh my goodness. Where you get dressed up for every meal that you eat and wow. Anyhow.
Yeah.
Okay. Present your conclusion in the form of an English statement. Okay, so what was our original research question? Or what was our this?
The null hypothesis was that it would not change, but we do see that it's greater, so we agreed to reject the hypothesis because
No, we failed to reject it, don't we? Does that mean?
Yeah, sorry, failed to reject it. I'm sorry.
P-value is less than. Okay, so the p-value is greater, so we failed to reject it. So we can say we are confident. Oh, that's when there's a confidence interval. I don't know. Not that articulate in statistics. Okay, let's see. How would we rephrase that? How would we rephrase that? Just that we failed to reject the alternative hypothesis. There was not significant evidence out of the 9 workers that completed 100. I don't know. Complete the 100 products with the new test or whatever. So I'm just rambling, huh? What does it say in the answer? What happened to all
Yeah, I
my...
think that sounded good, Mindy.
Oh, thank you for boosting my self-esteem there. Okay. Something like that. I don't know. You can phrase it better than I can. I failed to reject it. I don't know. What does the answer say?
The answer also says we have insufficient evidence to say that the time to take one of the products is any different after the implementation of the assembly procedure. And then H says, rather than testing a hypothesis, now say you just wanted to estimate the mean difference between wait time at the 95% level. What would you do? Do it and paste your results below.
Okay, so we look at what is at the 95%, what's that equation for confidence intervals? Okay. That would be x bar plus or minus z over sigma divided by the square root of n. So, and we know that the 95% interval is 1.96 is what that is on the applet or whatever.
Is that for the Z?
That would be the equivalent z-score or t-score for it.
Cool.
So, am I making sense?
Yeah.
Okay.
Then
So we're gonna take the x, instead of x bar, we're gonna do d bar because we're dealing with this particular task, the two means. So it's the same thing, right? So we would essentially do d bar plus or minus 1.96 and then sigma over. Okay, let's go with that.
So what did we get for d bar again?
I'm sorry?
What did we get for the d bar? Is that 1.06, right?
Yes, that is correct.
And the standard deviation is 2.
So at the 95% level, it's 1.96. And then sigma is the same thing as standard deviation. Okay.
So yeah, so for H, rather than testing hypotheses, we would do 95%.
We would compute using the 95% confidence interval. Are you actually typing it in not the spot? And you are supposed to do that, I guess.
Yeah. Yeah. So what did you get for that equation? Did you get 1.04 and 3.49?
So I must be calculating wrong. Okay. Let me try again.
Oh, actually, no, I did it wrong.
I got 2.752 for the first part of it. I haven't got the second part yet.
What did you get for the first one?
2.752?
Oh, okay.
No?
I just did the second one, so I'll do the subtract. No,
So what did you get for the second one then?
For the first one, I got negative 1.2 and 3.32.
Okay.
You've been there all night. You poor girl. What class?
Okay, so what were the two answers that you got for the 95% confidence interval?
I got the negative 1.04 and 3.49.
Okay, I'm not getting those. Okay, I'm just upset that I'm not holding them. Okay, you need to go to bed. I'm sorry. Okay, sorry.
That's okay.
It's one crying that's keeping the others awake. Okay, so how you set up the problem, maybe I'm setting it up wrong. It's 1.056 plus 1.96, and then you have 2.596 divided by square root of 9. Is that how you have it set up?
You have 1.056, you said?
Yes.
Oh, I think I...
Elena, she went, Tom. Guess we're too boring.
What did you get for your answers?
2.752 and negative 0.640, but those seem like really way off, so I don't know.
Yeah, I didn't get that. And it also didn't, on the key, it doesn't have anything, so.
Oh, okay. Then maybe we're weighing in too much on that. We at least know what to do, right?
Yeah, yeah.
Okay. We understand that that's what we would do. We would use the confidence interval equation.
Yeah. Yeah.
Okay.
And then
Yeah.
for number 5, it says that in a short paragraph we just describe the action we feel we should be taken based on statistical results above. So it doesn't
I know.
really.
What?
What were you gonna say?
I would say that I would probably increase my sample size in order to get a better, more accurate test results.
Yeah, me too. That makes sense.
And how did they? I mean, this unit's about double mean, so how did they compare, like before and after, like the two different I'm trying to remember. It was procedures
Yeah.
is what it was. Okay.
Yeah, I don't think they.
Okay.
I don't think it's a whole bunch. Like,
So okay. So they compare different times for 100 products. Okay. All right. I think it's just you and I. I think we're too boring for her.
okay.
Or maybe she had to go to the bathroom or something. I don't know. She's very quiet, so.
Yeah, she. Okay, so let's go ahead. Sorry.
I can't believe you and I doing a quiz. Oh no. Here we go. We can do it.
Well,
Yay. Okay. Let me
now we
get to
can.
it here. I know. Victoria helped me over the weekend. I was texting her and I was doing the group quiz that we could make up, and I was texting her. I'm like, yeah. So I wasn't asking her for the answers. I was just saying, okay, this is what I got, or da 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 da, and she kind of guided me along, so it was nice. Okay. Let me see. Go back to textbook. Don't even have my textbook open anymore. Okay. Okay, hold on a second. Then let me open it up again. I learn. If it's gonna let me.
Okay.
Okay. Oh, there's all my tabs. Okay. So we're going to group meeting. Okay, I'm on L12 group meeting. Start the quiz. Try to put up the screen at the same time. I can never seem to get them both up at the same time.
Yeah, I can't get like the whole screen.
Yeah, let me see if I can move them. I can move the test a little bit over, but then I can't see all the words. Yeah. Okay. All right. Kind of see each other that way. Okay.
Oh, there's Elena. Yeah. Hi, Elena.
Hi, sorry, my laptop died, and so I had to switch out batteries.
I thought we were too boring.
No.
Yeah, it is statistics. How exciting can that be? Yeah. Okay.
All right. Well, Elena, we're just about to take the quiz, so.
Okay.
How many questions are we facing here? Let's see. 16. Holy cow. Okay. Well, I guess we increase our odds. Okay.
All right. So, number 3 says, what is the value of the test statistic? So we just do the t equals x bar minus funny u s divided by.
All right. Let me get to my
I need this.
paper here.
Yeah, I tutor it. Well, I don't tutor.
So the x bar. So we get something.
So we're using the equation t equals x bar minus sigma over s divided by square root of n, right?
Yeah.
Okay. Okay.
Okay. So will we do
2.2 is the same as x bar. D bar being the same as x bar. And then
Oh, yeah, good job. Good job.
sigma.
Well, it's actually the funny U, so I think it's 0.
Okay.
So 2.2 minus 0 over the S, which is 3.3,
3.3. Okay.
divided by the square root of 9.
Okay.
Which with this, I get 2.2 divided by 3.3 divided. I got 2.
So did I.
Oh, good job. Cool. Bam. And then number 4. The probability of being greater than 2 is 0.0403. Use H, the alternative hypothesis, to determine the p-value for this test. Oh, okay. So now we just go to the normal, the probability applet, and to be greater, it says to be greater than 2.
So you highlight
the right side of it.
the right tail. Okay.
Uh-huh. So then the p-value.
I'm sorry, what do we put in the area? Do we put in 2 or we put in what it said greater? I'm sorry?
Yeah, we would put in 2.
Put in 2? 2.0 or 2? 2.
I put 2.000.
0, 0, yeah. Okay. Okay. Yeah.
And then I got 0.023. Just because we're rounding it to 3 decimal places.
Okay, I don't know why, but the applet never works for me, so I must be doing something wrong. Do you highlight first and then you enter the area number, the number in the area?
Yeah, that's what I do.
Okay, and then it changes on me every time. It's very annoying. Okay, so I put in the area 2.00. Maybe I need to add another 0. I don't know. And then nothing changes for me. Ah. Okay, what was the answer that you got, though?
I got 0.023.
0.023?
Yeah.
Okay.
Cool. And then number 5. So D, isn't that what we just...
Are you on the question 5 now?
Yeah.
Or the start of whatever that is? Okay.
Yeah. So do you just copy and paste all of those into SPSS?
Absolutely. That's the easiest way to do it. I've done it for other things too, yes. To just open up a new SPS, an empty one, spreadsheet.
Cool. Okay. And then you just paste it in there?
Okay. I pasted. There's 9. 9 of them. Okay.
So
What are we supposed to do with this?
Copy it.
Oh, wait. There's a lot. Oh, there's 2 groups. Oh, holy cow. Okay. Did you just highlight everything for the 2 groups and put it in one column?
No, mine's not able to do it. Like, I don't know how to copy and paste it. I mean, I thought I did, but it's not letting me do it.
Okay. I'm trying to think. Okay. Let me see what I can
type.
I'm sorry?
Oh. Holy Did you do it under type or?
You weren't able to like right click it and cut paste?
Yeah, that's what I'm trying to do.
Okay, so I'm highlighted the first group. I'm copying it. I'm gonna put it down in the first column in my new spreadsheet. Okay. Oops. I don't know why I did that. Okay. And then I'm going to go grab the other group.
Okay, let's see if I can.
Copy. Okay, so I have two columns. One starts with 202.09 and the other one starts with 234.19. Is that what you guys have?
I'm gonna have to play with mine because mine's just not letting me do it. So
Are you in Excel or SPSS?
I'm in SPSS, so I don't know if I'm just doing something wrong. Like I don't know
Did you
what
open
I'm.
a new data sheet, a new spreadsheet?
Yeah, I did. So I don't really know. I guess I'll just have to play with it a little after. So.
Okay, I'm just saying maybe it doesn't recognize. I'm trying to think what to do about that. Okay, so what's the next step? What we're supposed to do with this?
So then we're trying to find the D bar. So the D bar, isn't that the mean, right?
Right. So it's finding out the summary statistics basically is what we're doing. So you could probably just do a histogram and get it that way. So
Yeah.
let me see. Let's just go to graphs, legacy dialog. But before we do that, we have to do that step that you taught us where you do the difference. Do you remember how to do that?
Yeah, I do.
Go to transform.
Yes. So go to go to analyze.
Oh, is it analyze?
Yeah, so go to analyze and descriptive statistics. Wait, no. Go to file and then read text data. No, just open. There we go.
Just
File,
open.
Open.
What? I'm sorry.
Yeah, so
Read
you go
text data. Okay.
You go to file. No, so you go to file and then open, and then
I thought you just did transform. No.
That's for a different step.
Oh, okay.
So we do file and then open with the little arrow, and then there's data, and so we'll go into data.
Okay.
And then you'll have to click the one that you just put in.
I didn't title it, so I don't know, but it will come up. Let's see. Do I just put VA? I don't have a name for it. Untitled 2?
Yeah.
What's that?
Yeah, I would imagine it's that one.
Yeah. File not found. Okay, so it's probably the way I have it. I don't have an asterisk in front of it. Maybe that's why. Okay. Okay, that didn't do anything for me. Okay. Are you guys there?
Yeah, I am.
Okay. Were you able to get to that step?
No, mine just, for some reason, I'm not able to get in. I don't know why. I'll try.
think we need to go back to the... Elena, do you have any suggestions?
So I can't pull my SPSS up right now, so I was trying to do an Excel, but I'm not sure how.
Yeah, okay. So I can pull my SPSS up, but I'm not the captain of the ship. I'm not... Just kidding. So, I'm trying to remember if we can just skip the data part. Do you actually have to do that part, or can you go... Because I don't... All right. Hold on. Let's see. Let me go back to the textbook where I explained it again. Okay, so I went into transform. If you can get into SPS. And then I put in the target variable. I put in compute variable is what the choice I made in transform. And then I put in difference. And then I'm going to put in the first column, subtract the second column. Okay. Let's see if that comes up. Okay. So that gave me a histogram, but this is, no, never mind. This was the one we did before. It gave me that. So I didn't bring up anything new. Hold on a second then. Okay.
Oh. Yeah, I don't know what my thing is. It's just not letting me do anything. This is really frustrating. So what I could do, because isn't the D bar is just the means subtracted from each other, right?
You're right. All right. Okay, so I found out the difference. It looks like it did it. I calculated it. So I'm going to go to graphs, and then I'm going to go to legacy dialog, and I'm going to go to histogram. Oh, there. The same thing. I'm clicking on the variable difference, put it in the variable dialog box.
Cool.
I'm clicking OK. Okay, so I got a histogram. The mean is saying it's 31.03.
Okay. 31 point what?
31.03. Do you know how to send a screenshot? I wonder if I can send you a screenshot of what it looks like.
I don't.
I don't know how to do screen.
What are
I'm
all
sorry?
the numbers?
Okay, the
What
summary
are what's
statistic, yeah, is 31.03.
Okay, so
And
we
then
do,
the standard deviation. I'm sorry?
with the D bar, we do need to round that to 3 decimal places, so we could put 31.030.
Okay. All right. And the standard deviation is 341.157.
0.157.
Now the popular N
Yes.
is 20. Is that because it looks like it's more because you have 2 different values for each test, right?
Yeah.
Yeah. Okay. Because it looked like it was more when you look at the quiz, because you have the 2 groups, but it's okay. Group 1 and group 2. That's just because there's the pre and the after, the 2 tests for each study or test. Am I making sense?
Uh-huh.
Okay. All right. All right. I don't know how else for you to verify that I got the right answer if you can't get SBS. Are you going based on faith here?
Yeah, I am.
Hopefully I don't sink our ship here, guys.
It's okay.
So, okay. So the D bar then is 31.030.
Mm-hmm.
Okay, so I'm putting that in for number 5. Number 6, 341. Do you have to round? You said 1. It's 341.157. Is that how we put it in?
Yeah.
Okay. All right. So we need to find out the test statistic and the p-value now.
Okay, so I'm doing the test. So does the standard deviation seem large to you?
Absolutely, it does. I was trying to figure out if we need to do something about that.
I don't know.
Okay. Oh, let me see if I can send you a screenshot or something of what I just did. Oh.
So what
Neither of
does the
your
standard?
SBS is working? I'm sorry?
Yeah, mine's not. I don't know why.
Have you shut it down and like go back into it, something like that? I know it's something that we download, so
Yeah.
I'm trying to think how you could maybe make it work again.
So I got for the T, I actually think the standard deviation might be right. Well, it's probably right because there are some really big numbers and then some really small numbers.
That's true. Okay.
I think, and then I did get the T or the test
Oh, I
statistic, and
haven't calculated that yet. Okay, what did you get? I'll start calculating it here.
I got 0.407.
0.407?
Uh-huh.
Okay, so let's see. Our D bar is 31.03 minus 31.57. Sample size. Okay. Oh, we subtracted from 0, right? Is that what you said?
Correct, yeah.
Okay, so let me switch up that. And then standard deviation. See if I get your same answer here. Yep, I got that too. I had 0.406, but rounding it, yes.
Cool. Me too.
Okay.
Awesome. Perfect. So then with the p-value, we just stick that into the into the probability applet, right?
I'm sorry, what?
To find the p-value, don't we just stick that into the probability applet?
Yeah, I do.
And wouldn't we just do it on both tails? Wouldn't we highlight both tails? Does that sound right to you?
Let me just read the instructions one more time and see if there's any clues to that. Yeah, because it's saying equals crossed out, so that's a double tail. Yes.
Okay, cool. Cool. So yeah, so then for that, I got 0.684.
Okay, let me see what I get. Yes, 0.684. Yes, I got that too.
Cool. Perfect. And then for number 9, it says, what is the correct decision based on the evidence?
Okay, so it's going back to the p-value and the alpha. That's where you determine that.
Yeah, so the alpha is alpha equals 0.10. So if it's greater, then we fail to reject, right?
Let me go back to that information. What did I say? I'm trying to ingrain this in my brain. Okay. If the p-value is less than the alpha, you reject the null.
Okay. So then if it's greater, then we'll fail to reject it. So we
Yes.
will fail to reject it this time. Cool. Awesome.
6840. Okay, so p-value is 0.6840. What?
264 just because it's to 3 decimal places.
Oh yeah. Thank you. I need to be reminded of those things. Okay. So and then what did I say? We failed to reject? Yeah.
Correct. Yeah.
And then number 10, suppose your alternative hypothesis is greater than, what is the correct decision based on this evidence?
So,
Okay, so if it's greater than, what part are we highlighting on the applet?
yeah, that's what I'm trying to figure out.
Represent that.
Suppose
It's
you're all
greater than the whole. Wouldn't that mean that it's less than the alpha? I don't know. I'm confused. Let's see. Let me look at my notes.
I still think it would be fail to reject.
What is your reason for that?
Because I think if it's greater than 0, and you put it in the probability applet, then I think we would highlight the right tail,
Okay.
which would then it would still make it greater than the alpha, so we would fail to reject. But don't quote me on that.
I'm trying to find that little chart thing we had. Let's see. What do you think, Elena? Okay, are we dealing with where we know the sigma, right? We knew the sigma in this one. We don't have to deal with degrees of freedom or with that particular thing.
Yeah.
Okay, so that's not. Okay. We determined the p-value. Okay. Um. Excuse me.
So did you also get to fail to reject the null hypothesis?
I'm on the fence. I don't know.
Okay. Yeah, I'm not exactly sure, but we have a 50-50 chance, so.
Yeah. Yeah, we do have to get to this quiz. Okay, and we still have another group thing to do, 11 through 15, don't we?
Yeah. So
right.
I know that 11 is really easy. It says which is greater, n or df? And we know that the df is n minus 1, so we know
Right.
it's greater. So cool.
So n is greater, yes. Is that what you put?
Uh-huh, yeah.
Yeah. Okay.
Cool.
Your alternative hypothesis is, what's that mean? I forgot what does sigma sub d mean? Do you remember? I don't know. Not equal to 0, and use the level of significance of 0.01. What is the p-value?
Okay, so the p-value, so we'll just have to do all those steps, right?
Right.
Do the
Do we have
whole,
to go back up and take that data?
yeah.
This is from nosocomial infections, whatever that means. Okay. All right, so I'm going to open up a new spreadsheet, cut and paste it. Copy. Paste. Copy. Paste. Okay, is your SPS working or no?
No, it's not. So I'll just have to try to figure it out, because I am on a Mac, so maybe that's why it's different.
Oh, okay.
Yeah.
Hmm. Okay, well, I put in the 2 columns in the spreadsheet. Now I'm going to go and do the transform descriptive, whatever the next step is. So you won't see my face for the moment here. Okay, compute variable, and then I'm going to put in the target variable difference. Okay. Then I'm going to take the first one, put it in the numeric expression, subtract it, put the second, subtract it from that, click OK. That gives me difference, and then I'm going to go to graphs, legacy dialogues, and then go to histogram and click on difference in the variable, put it in the variable box with the arrow, click OK, and I just did a histogram to get the summary statistics to get our information. What was it asking for? I forgot.
Check. It is asking for the p-value.
P-value. Okay, so
We first need to find, we need to find the d-bar,
okay.
the mean, the difference of the means. And then after that, we'll find the standard deviation. And then with those two things, we'll find the test statistic, and then we can find the p-value.
Right. Okay. So the mean is 11.95.
11 point what?
I'm sorry, 11.95.
Okay.
The standard deviation is 15.003.
Okay. Perfect. Okay, so then I can help find the test statistic.
Okay.
So then our x is...
Okay.
Oh, that's 11.95.
Yeah. D-bar. Yeah.
Minus 0 over 15.003, and then the number of people, yeah, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, got 22.
Okay. You work faster than I do here. Hold on. Did you just divide it by 15.00, not 15.003, or did you do 15.003?
Yeah, I'm gonna do 0.003.
Yeah, okay. All right. So 11.95 divided by 15.003 times the root of square root of 22. 3.735.
Yeah, so I got 3.73, and then we'll round the 5 to a 6.
Okay, so 3.736, right? Because that's a 9 that we're looking at. Okay.
But then I got the
So you put that in. Uh-huh.
Do we put the p-value, or how would I say it? Because it is not equal to 0, so will it have both sides? Will it be, does that make sense? Will it be on the right and the left tail?
What was it originally in the data? Was it not equal to? Is that what we're doing with?
Yeah.
Okay, so that would be double tailed, wouldn't it? Didn't we learn that? Yeah.
So then we got 3.736. So then I got 1.8697 times 10 to the negative fourth. So if we do that, it would be 0.0001. 0.0001.
Did you get a huge number? 1.8697?
Times, like, and then e to the negative 4.
Right,
Is that
because
what
it's a huge number they put in scientific notation. Yeah.
Yeah, so
Or
that's,
expression.
yeah, so
Is
that
that
one,
right? Does that seem wrong?
I think it might be right because the level of significance is 0.01, and so I think if we were to just put 0.000, yeah, because yeah, I think that's right. You would just, I think, 0.000, and so since that is actually smaller than the level of significance, we would reject the null hypothesis.
All right, let me get back to. I have so many tabs open here.
Okay, that's fine.
Find the quiz again. Okay. Okay, so we're on number 12, right? Your alternative hypothesis is. Okay, so I'm sorry, I'm on number 12. The p-value is.
I got 0.000.
Not 1.8697 e to the fourth, or.
So that would be, so what the 1.8697 e to the negative 4, that actually, when it's the negative, we move the decimal to the left.
Oh, okay.
Yeah.
And then you got 0.00.
Yeah, I just got 0.000.
Okay. 0.000. Okay.
And then 13, because it's smaller than the level of significance, we would have to reject the null hypothesis.
Right. Right. Okay.
And then it says you decide to try another alternative hypothesis. This time you use less than or greater than 0, and you keep the same level of significance. Do p-value increase or decrease? Let's see.
Keep the same level of significance. Do the p-value increase or decrease? Okay, so what's changed?
So just one of the sides is
Greater, bigger.
yeah.
No, I don't know all the rules. My heart. Okay.
So I think it would get smaller. Actually, it would decrease.
You think it gets smaller?
Because if
My,
if the U is greater than 0, then we would make the right side, the right tail, be highlighted, and so with that, it would make the number a lot smaller, just because we don't have the left side being shaped.
oh, I get it. Okay, thanks for explaining that. So it's decreased. Okay.
And then what decision do you make? We would also reject the null hypothesis just because it's even smaller.
Okay. So 14 is decreased, 15 is reject the null hypothesis. Okay.
And then 16, as we have seen, the p-value depends on the alternative hypothesis. Setting aside the data in the problem, do you think a general rule can be made? Which alternative hypothesis will give the smallest p-value? I think the u sub d is greater than 0.
Choice
I
3, yeah.
I think that one would make the smallest p-value.
Because when you look at the applet, you're highlighting everything from the left, I mean the right of that tail.
Yeah, so then it would be a lot smaller. That's how I see it, so I hope that's right.
Okay. All right. I don't know. How do you feel about submitting it? Okay, let me just go to the last couple of problems real quickly with you. Okay, so which is greater, N or DF? I know N is greater, the sample. Number 12, it's 0.000. 13, reject the null hypothesis. 14, decrease. 15, what decision did you make? Reject the null. 16, sigma sub d is greater than O or 0.
Yeah,
The third
that's
choice.
so I hope that's right. I think that's right. So should we go ahead and submit it?
Well, it's, yeah, let's do it. I'll just close my eyes. Oh. All right, we got a B. Well, I got a B because I didn't do everything for the Why did I
Yeah.
get a B? Did you get a B too?
Yeah, I missed 3.
We missed 4 and 12 and
12
16.
and 16, yeah. Okay, well, I guess that makes sense that not enough information depends on the problem. I guess that makes sense. So,
Okay.
all right. Well, sounds good.
Well,
Well,
I'm glad to know that my information was correct. Since you
yeah,
could
good
open
job.
SPS. Yeah.
Yeah.
This class has been a real struggle for me if it's not obvious. So I'm actually failing it right now, and I almost withdrew it. And the professor or the instructor, I actually met with him twice last week, which was very nice of him to do that. So he's like, don't give up, just keep on, having your tutoring sessions and da da da. And I'm like, okay. And I think I'm really doing really well. I mean, you have access to everything to read you want when you take the test, but for some reason I still don't do it well on the individual tests. I did better this last week. I got better grades on my own, but yeah. So I'm struggling, but I'm not gonna give up. So.
Okay. Well, if you ever do need anything, like I know Victoria's always there to help you also, but if for some reason she's not there or you just need help, you can always text me and I'll because at my work I can pull out my computer. It's pretty relaxed.
Okay.
If you need any help, just text me and I can help you with it with anything you need.
Okay. I really appreciate that. Yeah, like right now I actually have a D in the class, so I'm not even at a passing level right now. So yeah. So hopefully I can bring up my grade. I've been trying to every week. So.
Yeah, so seriously, if you ever do need anything, just give me a text. So,
Okay. All right, that
all right.
sounds great. And when I talked to Mr. Brother Papa, he said, anytime you have